Hi everybody, welcome to our section 4.6 lecture video on exponents, order of operations, and complex fractions. In this section, honestly, there's nothing new. It's just putting things together. So all of our fraction operations, we're going to do them again, and we're going to use order of operations with them. And theoretically, you guys know your order of operations, and you know your operations with fractions. It's just combining all of that and giving it some practice, okay? So let's give it some practice. In example 1, it's just exponents with fractions. So I've got 2/7 raised to the third power. So what this means is 2/7 times 2/7 times 2/7. It's the fraction 2/7 multiplied by itself 3 times. Nothing simplifies, which is not surprising because 2/7 was already simplified. So there's nothing that's going to simplify here. We're just going to multiply straight across. 2 times 2 is 4, times 2 again would be 8. In the denominator, 7 times 7 is 49, and then 49 times 7 is 343. So our answer is 8 over 343. Let's do another one. I've got 1/3 to the fourth power times 9/5 to the second power. So what this means, just writing it out, is 1/3 multiplied by itself 4 times. So I'm going to have 1/3 times 1/3 times 1/3 times 1/3. And then that is multiplied by 9/5 2 times. So times 9/5 and times 9/5. This one we can actually simplify, which is kind of exciting. Because guess what 3 times 3 is? 3 times 3 is 9. So I'll have, that's a 9, and 9 and 9, or 9 divided by 9 would be 1. So you'd have a 9 here and a 9 there. So that would be simplified to 1 over 1. Guess what? I have another 9, which is pretty exciting. 3 times 3 is 9, and 9 divided by 9 would be 1. So this one simplified really nicely for me. It doesn't always work out quite that pretty. If we had an extra 3, obviously we couldn't do this, or one less 3, we would just simplify the 9 and the 3 to have a 3 on top. But this one worked out really nice. So I've got a bunch of 1s in the numerator, and 1 times 1 times 1 times 1 times 1 times 1 is 1. In the denominator, 1 times 1 times 1 times 1 times 5 would be 25. So our answer is 1 over 25 on that one. Alright, so let's get into the rest of our section here. So the rest of our section talks about complex fractions and order of operations. So let's talk about those things, and then we'll get into some more examples. So first off, what's a complex fraction? They look terrifying, and I promise they're not that bad. They look like a fraction inside of another fraction. So it's a fraction that has another fraction in the numerator and or the denominator. Okay, and you can see a couple of these down below, example A and D. So like in part A, we have 5/12 in the numerator and 4/15 in the denominator. That's what these look like, okay? And a quick review of our order of operations. In order of operations, first operations you should be doing involve parentheses if you have them. And remember, parentheses are these things, but you might also have brackets. We talked about a couple things that also on that same level, where if you have like an absolute value, you need to do those before anything else. If you have a giant fraction, which guess what? We're going to have those sometimes. Giant fractions, there are assumed parentheses in the numerator and denominator, so those things are first, okay? After parentheses are going to be exponents. After exponents comes multiplication and division. And after multiplication, division would be addition and subtraction. And just a quick reminder that multiplication and division are on the same level. So if you have more than one of them, you go left to right. You don't do multiplication before division. Necessarily, you go left to right if there's more than one on the same level. Same thing with addition and subtraction. You go left to right if you have more than one of them. Alright, let's get some examples going. So in example 1, it just says simplify each complex fraction. And I know these look pretty intimidating, but they're just a different way of writing things. So that 5/12 over 4/15, that's the exact same thing as 5/12 divided by 4/15, which is, I think, a less intimidating way of looking at it. So let's go from here. Remember that division is the same thing as multiplying by the reciprocal. So this is the same thing as 5/12 times the reciprocal, which would be 15/4. Then we can simplify if we can. So I notice that 15 and 12 are both divisible by 3. So I can divide by 3 in the numerator, divide by 3 in the denominator. And I think that's all I can do here. I know you might see, hey, there's a 5 and a 5. They're both in the numerator. They multiply together. They don't divide out. And same thing with the 4 and the 4. They're both in the denominator. They're going to multiply together. They won't divide out either. So let's go ahead and multiply straight across. We'll have 5 times 5, which is 25. We'll have 4 times 4, which is 16. And it is perfectly fine to answer as an improper fraction. Alright, we're done. We've got 25 over 16. Would you guys like to try the next one, since it's really similar? Good. So in part B, we got 11/20 over 5/33. So I'll give you guys a minute. See if you guys can try this one. And I will show you the answer here in 3, 2, 1. The answer you get should be 363 over 100. So what this looks like is 11 over 20 divided by 5 over 33, which would be the same thing as 11 over 20 times the reciprocal, which would be 33 over 5. Nothing simplifies. So you'll multiply straight across. 11 times 33 is 363. 20 times 5 is 100. Alright, let's do some more examples. These ones really were using the order of operations with all of these. Okay? So use the order of operations to simplify each expression. Okay. So first one is 1/4 divided by 9/4 times 3/5. This one doesn't have any parentheses, it doesn't have any exponents, so we're going straight to multiplication and division. It has both of these things, so that means I'm going left to right. I'm going to start with 1/4 divided by 9/4. So that's the same thing as 1/4 times the reciprocal times 4/9. The 4's are going to simplify nicely. I can divide by 4 in the denominator and the numerator. Then multiply straight across. 1 times 1 is 1. 1 times 9 is 9. Now that I've done that, I'm going to regroup with the rest of my problem. I'm going to multiply by 3/5. Okay? So I'm just bringing this down. With this multiplication, I can simplify first. I notice that 3 and 9 are both divisible by 3. So I can divide by 3 in the denominator, divide by 3 in the numerator, then multiply straight across. 1 times 1 is 1. 3 times 5 is 15. So my answer is 1 over 15. 1/15. Let's go on to another one. In part B, I have 3/2 divided by parentheses 5/24 plus 7/36. I do have parentheses in this one, so that's where I need to start. So inside my parentheses is addition. I know with fractions and addition that I need a common denominator. So my least common denominator with 24 and 36 is going to be 72. In case it takes you a little while to get there, I can do the work up top. So for 24, 24 is 4 times 6, 4 is 2 times 2, and 6 is 2 times 3. For 36, 36 is 6 and 6. 6 would be 2 times 3, and 6 is still 2 times 3. So for my least common denominator, I really have a lot of 2's and 3's, so who has the most? 24 has the most 2's, I need 3 2's. 36 has the most 3's, it has 2 of them, so I need 2 3's. Okay, so I'm looking at 2 times 2 times 2, which would be 8. 3 times 3, which would be 9. 8 times 9 would be 72 for my LCD on that one. Alright, to go from 24 to 72, I'm going to multiply by 3. And in case you're wondering, how did you do that so fast? 24 had 3 2's and a 3, right? This much. So it's missing the 3 over here. So that's what I need to multiply by to get to the 72. So if I multiply by 3 in the numerator and denominator, I'm going to get to 15 over 72. For the other one, 36 has 2 2's and 2 3's, so 2 2's and 2 3's would be this part of it. It's missing a 2, so I'm going to multiply by 2 to get there. So multiplying by 2 in the numerator and denominator, 7 times 2 is 14. So now I have 15 over 72 plus 14 over 72, which would be 29 over 72. Let's go ahead and regroup here. So bringing everything down, this would be 3 halves divided by 29 over 72. Division is the same as multiplying by the reciprocal, so I can rewrite this. It's 3 halves times 72 over 29. I can simplify a little bit. 2 and 72 are both divisible by 2, so I'll divide by 2 in the denominator, divide by 2 in the numerator, and multiply straight across. 3 times 36 is 108. 1 times 29 is 29, and I'm done. Okay, are you guys about ready to try one? Great. I'm gonna let you guys try part C, okay? It has 2 sets of parentheses, so you might want to start there. Go ahead and pause your video, work that one out, and then once you're done, you can unpause, and I will show you the answer here. In 3, 2, 1. As an answer, you should get 1 over 28. So what will happen is you'll do your addition and your subtraction first because they're in parentheses. So 2 sevenths would be 4 over 14 plus 3 over 14, which would be 7 over 14, which actually simplifies nicely to a half. In the other parenthesis, you'll have 4 over 14 minus 3 over 14, which will be 1 over 14. Then you're multiplying straight across. 1 times 1 is 1. 2 times 14 is 28. So our answer is 1 over 28. Alright, we've got 3 more example problems down there. I'm going to let you guys try those 3 at home, and I'm going to post the answers on Canvas so you guys can check yourselves when you're done. Good luck today, okay? Hope you have a great, oh goodness, hope you guys have a great week.